All right, so when we're talking dividing whole numbers, we have to remember that dividing whole numbers is the exact opposite of multiplying whole numbers. And if you recall back when we multiplied whole numbers, multiplying whole numbers was just by adding by groups. All right, so today we're going to subtract by groups. The interesting thing is we still have to make groups, which means there's a multiplication factor to this. Now, I'm going to give you a number, and then we're going to work this number. So I'm going to say 15,206. I'm going to divide that number by 21. Well, if we have trouble putting this into, well, how do I get this into my working division problem? Well, it is quite simple. Use things that you know work, right? We know 1 divided by 2. As we talked earlier, top to bottom is left to right, which means this is 1/2. I know that seems kind of corny to put that into a fraction, but we all know that 1/2 is 5/10. All right, so we're going to use this to relate. So top to bottom is left to right. We're going to use this to relate. 15,206. We're going to divide by 21. This number should give me a number well larger than 1. If you take, for example, here, I can't divide 2 into 1. It gives me a number less than 1. I know we're not into decimals at this point in time, but here again, this is a number that you should know. So this number should give me a number that is larger than 1, which means I cannot go 15,206 into 21. 15,000 will not go in to 21. So we're going to use 21 goes into 15,206. All right. Now, years and years and years ago, I too used to go 21 times 1, 21 times 2, and just sketch that stuff out. It works so much easier if we don't have to do that. Now, what I'm going to tell you is we're going to do less problems. Hopefully it makes us get to the end a little bit faster. It may not be exact because what I'm going to do is I'm going to estimate. I'm not going to use 21. I'm actually going to use and round this guy to 20. And then I'm only going to use 1 digit. Because if I can do 1 digit, it's not long division anymore. It's simple division. And simple division is, as they say, simple. So 2 doesn't go into 1, but 2 goes into 15 7 times without going over. Notice I'm saying 7 times. There's my groups. So I'm going to take 7, and I'm going to take it times 21. So when I take 7 times 21, I'm actually going to have to put the 7 over here, because 7 times 1 is 7, and 7 times 2 is 14. Now, I subtract that number. So here's my group. Here's 7 groups of 21. I'm subtracting it from 152. When I do, I should get an answer of 5. So that's my remainder off of subtracting 7 groups of 21 from this number. Now, I do realize there's other ways to set this up. This is just what's most common within my class. Now I get to drop, if there is another digit, I get to drop the next digit and do this all over again. 2 goes into 50 2 times. I multiply by the actual, which gets me 42. I subtract. I get a remainder of 8. Drop the next digit, which is 6. I'm going to come over here real quick, I hope, real quick. Drop this just a little bit down so you can see. I'm going to take this 2, goes into 86 4 times, so 4 comes up here. 4 groups of 21 is 84. Now, I get a remainder of 2, nothing else to drop. Please do me a favor. I know your book says this, and if I have you in class, if I'm fortunate to have you in class, I will tell you the same thing. Remainder 2 doesn't really mean anything. Are we almost done? Are we halfway done? It really doesn't tell us that. Okay? So yes, your book will put R2. Please don't do that. Okay? What I want is I want a remainder of 2 over 21. Now, unfortunately, this is unfortunately for you guys, it's a fraction. I understand that. But now it tells me that I just barely got done with 724 items. And I'm just working on my 725th item. I'm just barely there. Okay? This tells me more proportionally what it's out of. I have a better understanding of that. Please, you do not have to reduce this. We are not in fractions. So if that guy would have reduced, you don't have to do it. Leave it as this. This is exact. Do not change it as a decimal. I don't need you to use a calculator on it. We're dealing with whole numbers. And I know that's contradictory because we have a remainder. But you're going to end up with remainders. Okay? So that's how we do a long division problem. Have any questions? Go ahead and refer back to your book. Come back to this example.